Hello, everyone. So, this is the start of the SNAP related sessions. The first one, last lap for SNAP, right? So, we know that SNAP is a different beast of its own kind, right? Don't take it lightly. Uh, it's often said that um, not as difficult as CAT, but then whatever is easy is never easy because you're always competing against others, and your scoring and your competition is relative, right? Not absolute. So therefore, we have to get a very high accuracy and a lot of attempts to be able to uh, get the desired result, right? So therefore, in that spirit, these sessions will be taken up, whereby we'll be going through the questions which are of the SNAP level, and we'll be doing them in the spirit of the SNAP exam, which means we'll not be doing them. So they are 30-second, 45-second questions, right? Get them done like this, right? So that's the whole point, and therefore practice along with me and try to get your answers as fast as possible. All right. So with that spirit and in that mood, let's start Snap last lab. So let me just tell you that we'll be having, I'll be personally you'll be getting Snap a lot of sessions right from us. I'll be particularly taking all your quant sessions, as well as the last session that I'll take will be of DS, right? So although DS has not come in a long time in Snap particularly, but then again we should be aware about it because it can come up anytime, right? Even in CAT exams, DS has not come for a long time, but who knows? Okay. So let's start, people, with this. Here we go. So you should be knowing that CL has its Snap, ZAT, and MAT module, right, of online classes. So therefore, you can check out these details over here. You can scan this and get to know about our module, right? Okay. So here we go. The first one. Ram spends 80% of his annual salary if his annual salary increased by 14% and his expenses increase by 10%. His savings would increase by 10, 20, 30, or 40. How much percentage? Salary is increasing, expenses are also increasing, and savings should also increase. So let's see what happens. Since no numbers are given in all such questions, you so only percentages are given. So you can assume, you can start the problem by assuming something. Assume a value for, obviously, that initial salary we can take, and 100 is the easiest number in these kind of questions. So let's say that initially his salary was 100 rupees. Okay, how much was he spending? How much was his expense? 80 rupees. He was spending 80%. So how much was he saving? His savings were 20 rupees. Now in the new scenario, what happens? His salary increases by 14%. So 100, 14% increase, 114. And expenses increase by 10%. So 80, 10% increase, 88. Okay, so therefore we can find the difference to be the savings, 114 minus 88, which is what? 26. So if it is 26, it means that from 20, how much percentage increase? 20 into 1.3 is 26. So it's a 30% increase, obviously, right? So problem becomes simple when you assume the values, right? Okay, right? Let's see. Next one, time and distance. Okay. A person takes 20 minutes more to cover a certain distance as he decreased his speed by 20%. So if he'll decrease his speed, obviously he will increase, and time increases by 20 minutes. The time taken to cover the distance at the original speed is asked. So at the original speed uh, versus the new speed, what is happening to the speed? It is changing. It is decreasing by 20%. So can I say the new speed is 80% of the old, or 80% is 4 by 5? So it's 4/5 of the old speed, right? So in time and distance, when distance is constant, speed and time are inversely proportional, right? Speed is inversely related to the time, or time is inversely proportional to speed when distance is constant, because distance is speed into time. So if speed has become 4/5 of the whole old speed, it means that the new time taken must have become 5 by 4 times of the old time. That is the meaning of inverse proportionality. 4/5 speed, so time 5 by 4 times, inverse, right? So therefore, can I say that the difference is, the difference is given 20 minutes more. So the new time can I say 1/4 more than the old time? It is, new time is old time plus 1/4 of old time. So that 1/4 of the old time is that difference of 20 minutes. So I guess we are getting the old time to be what? 80 minutes. So therefore 80 minutes or 1 hour and 20 minutes. Isn't it? Okay, so people, you're not giving me the answers. What's happening? This is not a monologue. This is not a one-way session. This is a live session, and you are supposed to share with me your answers and beat me. Get your answer faster than I'm solving it, and give me your answer. Speak it out on the chat box. Okay, I know there are a lot of people on the session. Okay, so here we go. Next one, age problem. The present age of a father is thrice that of his son. 15 years hence, he will be twice the son's age. How many years ago was the father 6 times the son's age? Here we go. Simple one, age problem. Let's say son is X years old currently. So how much is father right now? 3x, right? So what happens 15 years later? He'll be twice of the son's age. So what is the equation we can write? After 15 years, father will be 3x plus 15, son will be x plus 15, and 3x plus 15 would have then become twice of x plus 15. Is the simple equation to solve your x. So just solve it. 3x plus 15 is 2x plus 30. X is 30. X is 30 minus 15, or x is 15. So therefore, at present, this is the present situation. Son is basically 15 years old and father is basically 45 years old. This is the present. Now, the question is not asking what is the present age. Question is asking something else. How many years ago was the father 6 times of the son? Now we can just check from the options what happens from the options. If I go 5 years back, so son was 10, 15 minus 5, father was 40. So this is not 6 times, this is 4 times rather. 6 years ago, son was 15 minus 6, 9. Father was 45 minus 6, 39. No, it's not 6 times. 10 years ago, son was 5 years. He was 35 years. It is rather 7 times. Only one option is left. 9 years ago, son was 15 minus 6, 9. And father was 45 minus 9, 36. Oh, sorry, 15 minus 9, 6. Sorry, 15 minus 9, 6. And father was 45 minus 9, 36. Yes, this is what he wanted. Right, so the answer is 9 years ago again. Nobody gave the answer. Yes, people, these are 30-second, 45-second questions. That is what you're preparing for. Less than 45 seconds, less than a minute, right? So get into that mold, right? You have to get into that difference. It's a 60 minute, 60 question paper, right? So you have to like crack it out, right? Okay. So, will you give me the answer for the next one or not? Here we go. A trader marked up the price of an item by 60%. When the discount was decreased from 20 to 10%, his profit increased by a 120 rupee. What's the cost of the product? Here we go. Again, so in this question, we don't know the cost. We have to find the cost. Let's take it as a variable. Now, mostly what happens, or mostly what people do is they take it as X. In these percentage based questions, always helps to take the total to be a multiple of 100. 100 is always the most convenient number when solving percentage based problems. So let's say 100x was the cost. Now there are two scenarios because the discount percentage is changing. So initially, if we say that the cost was 100x, then the marked price was 160x based on the 60% markup. In the new scenario, also that holds the same, that 100x has been marked up as 160x. We are trying to find this x, right? What we now know is that this final selling price, in the initial scenario, the discount given was 20%. So you decrease 160 by 20%, means you take 80% of 160. 80% of 160x is what? 128x. That was your initial selling price. You're getting a 28% overall profit. Now, in the new scenario, you're giving a 10% discount only. So your selling price now is is rather 90% of 160x, a higher value, and hence you're having your profit is increasing by 120 rupees. So this is 144x, 90%. Thank you there. Thank you, Arijit. लोग जाग गए हैं. Thank you. Very good. Right. Correct. So this difference is basically your 120 rupees, right? So this difference is what? 116x, and 16x is 120, right? So therefore you have to find your 100x, your initial cost. 16x is 120, so you have to find 100x, which means you have to find 100 by 16 into 120, which is what? 25, 4, 4, 30, 25 into 30, what? 750, right? Option B, that is your cost, right? In this case, I did take a small variable because from there I had to fetch the further values from cost. I have to basically relate what is the selling price in terms of that, and then write the equation for 120 rupees, right? Perfect. Okay, good. Here we go. Next one. Okay, I'll give you a few seconds for this. I'll just hold for a minute to let you try this one. What is the average of all the 3-digit numbers which are multiples of 11? Very good, Dharya. Thank you. I think you know the concept and trick. Yes. So it's an AP, isn't it? That we're talking of. Isn't this an arithmetic progression? Multiples of 11 is an AP. 11, 22, 33, 44, dot, dot, dot. It's not starting from 11, but wherever it's starting from 110. So basically the concept that you should know is that in an AP, the average of an arithmetic progression is always the average of the first and the last numbers, right? So take the average on the first and the last numbers. That is always the average of an AP, and that's how you can do this very quickly. So this sequence is starting from what? 110, right? 99 was not a 3D number. It starts from 110, then 121, then 132, and so on until dot 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 what? 11 into 90 will be 990, and then that's the last term, right? After that it will be 1001. That will be out of the boundary. So therefore your required average is nothing but the average of the first number and the last number, which means you have to do 110 plus 990 by 2, which is 1100 by 2, which is your 550, is your average of these numbers. Right. Perfect. Yeah, so very important concept of AP. You can take the average by taking the average of the first and the last numbers. All right. Also, to add to this, sometimes when we have a very small group of numbers and it's an odd list of numbers, then the average is also the middle term, right? For example, if we have 25 numbers, then the 13th number, which lies exactly in the middle, is the average of an AP, right? So that only works when the number of terms is odd, but in every which way, it always works as the average of the first and the last. Okay. Another question on average. Yes, everybody can do this. Right? Yes, everybody can do this. Okay, so what it is? Average runs scored by a batsman who has played 52 innings increased by one after an innings of 126. So we have to find the average, right? So you can create a simple equation for this. Let's say A was the initial average. So 52 into A was the initial number of runs made. Then you add a 126 to that. So this is the final total number of runs. This is the total number of runs for which the new average is one more. So it is A plus 1 and the number of innings is 53. So that's our equation. 52A plus 126 should be equal to A plus 1 times 53. Just solve this, you get your answer. So 53A plus 53. So 53 minus 52A is coming to be what? 126 minus 53. Yeah, so simple, very simple question. Average is 73. So initial average was 73 and now the average has become 74, right? More conceptually speaking, I mean, this is the very simple question, right? You can create an equation, or to understand this more conceptually, that 126 run created one more extra run for every inning. So for 53 innings in total, it brought in one more extra run. So this 126 should be 53 more than the current average. That is a logical way to think about it, right? So therefore, 126 minus 53, which is 73. Okay, here we go. Next one. Oh, linear equations, and there's an option of cannot be determined also. That is always creating problem, right? Forcing us to think, can we get the unique answer or not? Okay, so I'll give you a second to try this. What do you say, people? Okay, so time up for this one. There has it in. Okay, there. Let's check. Okay. So basically, let's say he has got X pencils and Y erasers. So 8x plus 5y is 67. So we have to find the values of x and y which satisfy this equation, right? Or 8x is 67 minus 5y. So 67 minus a multiple of 5 should be a multiple of 8. So start putting values of y as 1, 2, 3 until you hit a multiple of 8. So what the values you get? You get the values which is 67 minus 562, then minus 557, then minus 552, none of which are multiples of 8 so far, then minus 5. Okay, I don't even have to check multiples of 5, my odd numbers here. So can I say I just will do minus 10 now, because doing minus 5 gives me an odd number. So 52 ke baad I'll see 42, which is also not, but then 32. Finally, I reach a multiple of 8 when I get 32. So what I've done, 67 minus 35. So basically 8 into 4 is 32 plus 5 into 7 is 35. 32 plus 35 is 67. So one of the ways he could have bought these items for 67 rupees is buying 11 items in total. But since there is an option of CBD also, so we should just be very sure. Is this the only possibility? Well, yes, definitely, because if you keep on doing minus 10, you don't get another multiple of 8 further, right? 12, 10, 22, 12, 2. So therefore, that is the unique answer. There is no other combination such that a multiple of 8 and a multiple of 5 adds up to 67 exactly. There is only one solution over there, right? Let me explain the in-depth logic behind this question, right? Um, the logic is that whenever you have a linear equation in two variables and you have to find the integer solution, basically, right? That's the whole point of this question, is that you have to find the integer solution of this problem. So you have to find the first solution by hidden trial always. There is no two ways about it. You have to search for it as we did manually, right? 8x is 67 minus 5y. Keep on subtracting multiples of 5 from 67 until you hit upon a multiple of 8. And then you got your first solution that x is 4, y is 7. 8 4s are 32, 7 5s are 35, 32 plus 35, 67. Now, the point is, any other solutions of x and y can be always obtained by interchanging the values of x and y in terms of the other variables coefficient, which means that if you want another integer solution, then x is 4, coefficient of y is 5. You have to change the value of x by 5, whether increase by 5 or decrease by 5. You can't decrease by 5. You can, but mathematically there is a solution over here for this equation, but then minus value is not logical in the context of the problem, right? Mathematically speaking, another solution that satisfies this equation, integer solution, is decrease x value by 5, the quotient of y, and increase the value of y, because if you're decreasing this, you'll have to increase this to balance out. You have to increase the value of y by the quotient of x, which is 8. So 7 plus 8, 15. So mathematically speaking, minus 115 is also a mathematical solution, but not a valid solution in context of the problem, because it does satisfy minus 1 into 8 minus 8 plus 15 into 5, 75 is indeed 67. But obviously that has to be rejected. So therefore there is no other solution, right? Likewise, you could also have decreased y by 8, but then again you will reach minus 1 over here, the same situation, right? And you'll say there is no positive integer solution except for 4 and 7, right? So there, I hope you have noted, it was not 10, it was 11, and that is how you get this. That is the logic behind this question. Okay, let's move to the next one. Here we go. Okay, series, right? Find the next term. I'm sure you are practicing these kind of questions also, right? So let's see if you can understand the pattern over here. Right? What's happening? What are these numbers doing? So you can see that the numbers first start to decrease slightly, and then they lift up slightly, and then they start to increase quite rapidly. So that is a very common pattern in series problems. And this is typically a multiplication series, which means you are multiplying by some fractions over here. Because only when you multiply with the fraction, you can decrease the number. So you see, in these questions, you should try to look at the ratio over here. Thank you, there. So look at the ratio of the numbers at the last. 40 into what is 105 approximately, like 40 into 2.5 is 100. Okay, 18 and 40. So 18 into 2 is 36. So you can see the multiplication is happening, the multiplication effect, and plus some other constant is also there. So at the last, you can see this is into 2.500 plus 5, and this is into 2.536 plus 4 into 2, sorry, not 2.5, into 2, 36 plus 4. So you have now got the pattern, right? The multipliers are incrementing by 0.5, and the constants that you're adding are also changing by 1. So you expect into 1.5 plus 3 to happen over here as per the continuing logic, and that is fitting. Into 1.5 15, 10 into 1.5 15 plus 3 is matching. You can confirm here also, is that matching? Yes. Into 1 plus 2 should be what is happening. Yes, that is what is happening. Here it should be into 1 into 0.5 plus 1. Yes, that is what is happening. 14 into 0.57 plus 1, 8. So what you need to now know, what you now need to do is continuing this pattern into 3 plus 6. So 105 into 3 is 315 plus 6 is 321. Right? So a very common pattern. So something to take note, right? When you see this kind of a swing, right? First it goes down, then it starts gradually increasing, and then rapidly increasing. So that's typically this kind of logic, right? And to increase the complexity, not only multiplication, but also some constants were being added along with that. Perfect. You are brilliant people, right? Thank you, Rajit. Let's see. Here we go. Oh, Oh, geometry. Yes, people, geometry. Now, this is a very interesting question that I've put over here. I'll pause for a minute. Let's see if you can get this. Let me start discussing. So, we have been given in a rectangle ABCD that the diagonals intersect at ABCD. The diagonals intersect at P, and they do at a 150-degree angle, right? This is P, that's 150-degree. AC, the diagonal length is given as 50, and APB angle is 150. You have to find the area of the rectangle. Right. So people, uh, if you get into the geometry of the problem, it becomes a bit not so very easy to handle. The reason being, if you try to analyze this triangle APB, then the angles are not something that we can easily work with. Right? It requires a little bit in-depth trigo, because we get into 15-degree angle, isn't it? Because if it is 150, then obviously both these angles are equal, and they'll be 15-degree each. So then the geometry becomes a bit tedious, because you have AP equal to PB equal to CD, CP is equal to CD. All of them will be all obviously equal. Diagonals bisect each other in a rectangle, and they'll be 25 each, right? 50, half of that. Now you do know the triangle completely. All the angles are known, two sides are known. You can find this AB. You need to use the cosine rule, but that's a very long process. You can use the cosine rule to get that. Now I have a very shortcut to this question, right? I don't know how many of you know this formula. This is a general formula, the area of any quadrilateral. I'm giving you a general formula. In case you don't know this formula is very useful in this question. The area of any quadrilateral where, I'm not saying rectangle, I'm not saying trapezium, and I'm not saying rhombus, I'm saying any quadrilateral, remember, in which the diagonals intersect at the angle theta, and the two diagonals are of length d1 and d2, area of a quadrilateral is always given by half d1 d2 sine theta. Here theta is the angle of intersection. The information in this question is exactly given in that way to get the answer in 30 seconds, one line answer, if you know this formula, right? So the area is half d1 d2, each of which are 50. So half into 50 into 50 into sine 150 degree. Now you now need to know sine for 150 degree. You now need to know that sine 180 minus theta is the same as sine theta. So 150 degree will be the same as sine 30 degree. So this will be half. So our answer becomes what? 2500 by 4, 625 centimeter square is your area. Right? So the geometry of the problem is very tedious, but if you know this formula, the answer is very straightforward, isn't it? So in case you don't know this formula, something that I have added to your knowledge, half d1 d2 sine theta is a very useful formula in quadrilateral area, right? Okay, let's see next one. Here we go. Probability. Okay, you can do this, I know. The last one was a bit tricky, I know, but this is pretty straightforward. Everybody can do this. So waiting for your answers. Yes. Okay, good, Dere. Yes. So we have Yes, that's the correct answer. Thank you. So time out, right? Because one person has already done this. So probability is always favorable ways over total ways. You have to just find both of them. What is total ways? You have a total of 12 balls, 6 and 4, 10 into 12 balls. You're selecting two of them. So 12C2, the total number of ways to select any two balls from these balls. And then favorable event is that you're selecting two balls of different colors, right? What is the probability that they're of different colors? So you have to see all the possibilities. You can select either red and black, red and blue, or you can select red and green, or you can select blue and green. So red and blue, how many ways you can do? 6 into 4 ways. 6 ways to select the first ball, 4 ways to select the second one. 6 into 4 plus 4 into 2, blue and green, plus 6 into 2, red and green. So that's your answer. That's your value. What is 12C2? 12C2 is 12 into 11 by 2, or 6 into 11, 66. N into n minus 1 by 2 is NC2. So 12 into 11 by 2, 66. And this is 6 into 4, 24. Plus 4 to the 8. Plus 6 to the 12. 24 and 8, 32. And 12 is 44. 44 by 66 is 2 by 3. Right? So that's your answer. Okay. So people, I hope that you get the point of this, right? That how you have to mold yourself to a different kind of an exam, right? I have tried to push you towards that speed, right? And that is what you have to do. Okay, so this was our first session, and we'll keep on meeting regularly for the snap session. You'll have other sessions too. I'll be particularly meeting you for quant and DS, right? So hoping to see you quite soon, right? Thank you, all the best, right? We'll see you quite soon. Career Launcher mobile app is here. Make use of our app as well as for your, it's a very useful tool that we have developed for learning, available on both iOS and Android, right? So if you are not aware, you can use this. Check it out. Amongst the many apps on your phone, perhaps this can be something that really is of utility. Okay. Thank you. Thank you, people. I'll see you again. Ask me a question, send me any doubts, anything, any particular thing that any particular topic. If you want me to take up in the next meeting, you can let me know on the chat box. I'll come up with the uh, you know corresponding type of questions, because I always bring questions from my own side, right? I always bring questions which are relevant. I have studied the pattern and I know what kind of questions come across. So whatever is your challenge area, you can let me know. I'll include more questions of that kind. All right. So thank you so much. See you again, right? Thank you so much. All the best. Thank you.